So in this video, we're going to be estimating the value of non-perfect squares using a couple of tools. And so the first tool that I can consider is the area model tool. Could I build a perfect square that has an area of 77 units squared? How long would each side length represent? You might be thinking, well, there isn't a number. So another tool that you could use are the perfect squares that are on either side of 77. For example, 8 squared is equivalent to 64. And so the square root of 64 is 8. But we're looking for an estimation for the square root of 77. So it's going to be a little bit bigger than 8. Let's try 9. 9 squared has a value of 81. The square root of 81 is 9. But we're looking for the square root of 77. And so another tool that we could use is a number line tool. I know that the square root of 77, that value is on a number line between the whole number 8 and the whole number 9. Is it closer to 8 or is it closer to 9? For the square root of 77, that value is going to be a decimal number closer to 9. So we're going to make an estimation of somewhere closer to 9 on the number line. The last tool that we're going to use is our calculator. So you can use any of the calculator options at the beginning of the slideshow and type in the square root of 77. You'll notice that you do get a decimal answer like we've already established, but that decimal answer is actually an irrational number. Square roots that do not have perfect answer, non-perfect square roots, are called irrational numbers. And so the square root of 77 using our calculator is a decimal number, an irrational number that continues 8.7749. Now wait a minute, you're probably thinking, do I really have to write all those numbers down? Well, this value is irrational, so it's going to keep going. We can estimate this and round it by using the digits here to the nearest tenths place, 8 and 8 tenths, the nearest hundredths place, and even the nearest thousandths place. So it just depends on what the problem might be asking you to do.